Remember our keybuf code from one of the introduction lectures? We had a vector of ints and only wanted to keep the even ones. Instead of writing isEven as a global function, we can also write it as a lambda expression and assign it to an object called isEven. We can use it the same way as before, but it demonstrates nicely how functions are data too. But we do not have to assign the lambda to a variable, we can also use it as an anonymous function inline. So, what do the different parts of such a lambda expression mean? A lambda in C++ consists of a capture list, parameters, and of course a function body. The return type is optional. In many cases, the compiler can deduce it from the return statement in the body, but it is good practice and a kind of documentation to write it down explicitly anyway. Let's have a look at another example. The capture list is empty in that case. This means that the function body does not have access to any variables declared outside of it. But in some cases we want to have exactly that. In such a case we need to capture a value. This is a capture by value. Capturing by reference also works. Capturing by reference means that val inside of the body is affected by mutations to val outside the body. But if we capture by value, we do not have to think about mutation. If val would run out of scope in the capture by reference case, we would have a dangling reference inside at val. Capturing by value avoids this problem too. How can val run out of scope before add_value does, you ask? We could return add_value from a function and use it outside of it. Val would then be out of scope, but add_value would continue to exist. A lambda function including its captured values is called a closure. Since C++14, lambdas can also have their parameters declared as auto, which means we can use them like function templates. This comes in handy not only when we do not want to write out the type of the parameter, but the compiler can also deduce it in case we are inside a function template and do not know the type it will be instantiated with yet. The next lecture contains a programming challenge in which you will write a lambda function to solve a specific problem.